final question, nice little connected particle stuff. So there's our diagram. We're going to need to draw a new diagram for that though, I think. And here's our initial question, showing that the resistance is going to be 500. In order to do that, let's start off with, as I said, a little diagram. So if we have, what we've got is we've got one particle here which is 600 kilograms, 600 kg, and we've got tension in the tow bar going one way and the other, equal and opposite, and then we've got the car being how big is that? It's 800, isn't it? And that is being pulled forward with a force of 1,740, and we know that the resistance to the car is 400, and then we've got R going back there. Now, in terms of, if we consider the whole system, we can get R in one go because the T cancels out with the T. So if we write a whole system, it's always important to identify what it is you're talking about at any one moment, especially when you're showing something. Then we'd have force equals ma, so the force is going to be 1,740 minus r is going to be equal to the whole weight times the acceleration, so that'll be 1,400 kilograms, and the acceleration is 0.6. I should have that on our diagram. And times 0.6. So we work that out, and that gives us oh, and we've got minus 400 as well, haven't we? Sorry, minus 400. Pretend I wrote that on the line there. So if I take 400 away from that, I get 1340. And then I'm going to need to take away my 0.6 times 1400, which is 840. And that's going to be equal to R, which is 500 newtons as required. Then it says find the value of T when the tension in the tow bar is T newtons. So we can do this either with just the trailer, or we can do it with just the car. We've got to consider one of them though. So if I just, right, so the trailer is going to, the trailer's the easiest one because it's just the tension minus R, which is 500, is going to be equal to, so we're always using F equals ma, by the way, is going to be the mass of the trailer is 600 times the acceleration, which is 0.6. And that's going to give us the tension being 360 plus the 500 is equal to 860 newtons. Now you may, so you could do it that way, but we may as well just show that it's true for the car as well, because it's always reassuring if you've got time to do it both ways, and if it works, if you get the same answer, then you almost certainly must have done the right thing. So for the car, you've got 1,740, take the 400, take the tension, and that is going to be equal to 800 times 0.6. So if I take the 400 away, that's 1340, minus, that's going to be 480, so if we take the 480 away, that's going to be equal to T. Take 480 away from 1340 is indeed 860 newtons, so it still works. part 2, at the instance when this, so if it breaks, then we need a new model, which is it's a much simpler model. You've just got your trailer who's got a resistance of 500 newtons, and it's got no force pulling it, but it's still 600 kilograms, and it's got an initial velocity of 12.5 meters per second. So F equals ma. You've got you've got minus 500, because it's going against it, isn't it? Is going to be equal to, the mass is 600 times the acceleration. So then you can just say minus 500 over 600 is equal to A, which is equal to minus 5/6. Therefore, the deceleration equals 5/6 meters per second squared. Then finding the value of d, so that's the distance that it goes by the time it comes to rest. So we're going to be having the acceleration being minus 5/6. We've got the initial speed being, or velocity, being 12.5, and the final velocity being 0. So looking at the suvat equations, if you use v squared equals u squared plus 2as, that's going to give us 0 squared is going to be equal to 12.5 squared minus 5/3 is minus 5/3. If we use d for the distance, then if we add that to the other side, so yeah, then 12.5 squared is 156.25. If we divide that by 5/3, that's going to be d, which is 93.75 meters equals 93.8 meters to 3 significant figures. And finally, 2 different reasons why the answer is likely to be different. Well, air resistance will vary as the trailer slows. That's one that you could do. Also, the resistance applied by friction from the road will change as the trailer slows down. In reality, it'd probably be true, wouldn't it? So it's unlikely to be uniform deceleration. Also, you could say something about the road being unlikely to be totally flat. Anything that makes sense like that should do the job. Okay, folks, cheerio.